Hello beautiful people, Miss Beeching here. In this video we're going to have a look at Venn diagrams and two-way tables. For this skill we're just going to look at interpreting them and understanding them rather than being able to do stuff with them or draw them, just so you can get an idea of how they work. So a two-way table will look something like this. Okay, usually we've got two different events showing up on the two-way table. So you can see that this is one set of events, and generally up the top it's going to be like the event and then the not event. So here we've got likes coffee, and then we've got the not event, which is not liking coffee. And then our second set of events is on the other side. So we've got likes tea, and we've got not liking tea. The rest of this two-way table is either going to have numbers, which will be frequencies. So if they're whole numbers, it'll be a frequency. And we mentioned in the last video that a frequency is just counting how many things there are. So in this table, the numbers are going to represent people. Sometimes there'll be probabilities, and you'll be able to tell because there'll be decimal numbers or fractions. We're not going to look at ones that had probabilities in them for this skill, but there are two-way tables that have them. Okay, so let's go through each of the boxes and check what they mean. So this box here says that there's 43 people that like coffee and like tea. Okay, this box here says that there's 18 people who don't like coffee but they do like tea. And we can keep going, right? 25 people like coffee but don't like tea. And then 14 people don't like coffee and don't like tea. So those are the four boxes in the middle. And one thing that confuses people sometimes is these boxes on the outside. So in total, all of the people are in these four boxes. And those numbers add up to 100 if you go through and add them up. And you might notice that this box over here has 100 written in it. That's the total number of people altogether. Now what about these boxes and these boxes? These are also totals, but they're totals for each separate category. So this 61 is the total number of people who like tea. You can see it's across from the likes tea row. And you might also notice that if you add up the number of people who like coffee and tea and the number of people who don't like coffee and like tea, these two numbers added together equal 61. So the rows are going to add up to equal the total. And we can do the same thing for the row below it. So we can say, all right, well, there's 25 people who don't like tea and like coffee, and there's 14 people who don't like tea and don't like coffee. So again, we can add them up, and there's 39 people total who don't like tea. Okay, and the same thing works vertically. I'm not going to go through the addition again, but here we've got 68 people who like coffee, these two added together, and we've got 32 people who don't like coffee, those two added together. Now the last part of it all adding together is that you'll notice, and it kind of makes sense if you think about it, is that if we add up the number of people who like tea and the people who don't like tea, we get the total number of people. Because people are either going to like tea or not. There's no other category, so that's all the people. And we can do the same thing for the coffee as well. So there's 68 people who like coffee, and there's 32 people who don't like coffee. You can either like coffee or you don't like coffee. So there's 100 people total who fit into those two categories. Sometimes people get a little confused when they're doing that. We'll do a quick example later on in the video on how to fill in blanks, but it basically just boils down to checking that these two numbers are going to add up to this. These two numbers add up to this, vertically, horizontally, everything adds up together. So that's a two-way table. Let's have a look at a Venn diagram. And you've probably seen these before, but you might not be very familiar with them in a probability context. And we're actually going to do a Venn diagram for the same example. So we're going to talk about tea and coffee again, and the numbers are going to be the same as well. So here's a Venn diagram for our drinking or liking coffee and tea. Venn diagrams often have just two circles. Sometimes they can have more than two, and they can be arranged in a bunch of different ways. Most of the ones we're going to look at in this skill just have 2 circles for now though. So you'll see that this circle here is all the tea drinkers, and this circle here is all the coffee drinkers. You'll also notice that there's a box around the outside, and this might be the part that you haven't seen before, and there's this number written outside the box. So if you have a think about the fact that each of these circles are people who like tea and like coffee, anybody who's outside those circles must be the people who don't like tea and they don't like coffee, right? So the number on the outside just shows people or things who don't fit into any category. You'll also notice that there's this overlap section in the middle. So they're part of both circles, which means that they like tea and they like coffee. One thing that people got tricked on a lot in the pre-test that I'm going to point out is there was a question that was sort of like, how many people like coffee? And you can have a think about what your answer would be. And a lot of people got an incorrect answer of 25. Okay, that answer is incorrect because they saw this and they're like, oh, likes coffee, it must match up. But that's not quite right. There's 25 people who like coffee and don't like tea. But we've forgotten about these 43 people who still like coffee, but they also like tea. And they're still part of this whole circle. All of the people who like coffee are in that circle, not just this side with the 25. So actually, there are 43 people plus 25 people who like coffee. So in total, we add them together and we get 68 people. So just be careful when you're answering questions about Venn diagrams because a lot of people fell for this trick and it's the reason a lot of people missed out on getting this skill fully ticked off. Those are the main things I think for this diagram. Again, like I mentioned earlier, Venn diagrams can have frequencies. Sometimes they have probabilities in them and sometimes they have neither. Sometimes you'll have all the outcomes listed in the Venn diagram. So if we look at this example down here, and let's zoom in a little, we've got a list of numbers up the top. Ooh, let's go over here. We've got a list of numbers up the top, 10, 5, 25, 31, and 8. And then these numbers have been written in the boxes. So 10 is in the 5 times tables, but it's not an odd number. And then you see how 2 numbers have been written here. So each individual outcome is in the Venn diagram instead of just having a frequency there. So 5 and 25 are both odd numbers and they're in the 5 times table, so they belong in the middle. And then 31 is an odd number, but it's not in the times table, 5 times table, so it goes here. And then 8's out by itself being lonely because it's not an odd number and it's not in the 5 times tables, poor 8. Okay, fabulous. Let's quickly do an example of filling in a two-way table that has been partially filled. And I'm going to pause for a second, chuck that in for you. Okay, so I popped in a two-way table. This one's a bit American, but we'll excuse it just because it's still helpful for us to learn about it. So this one's got, I presume this is about students who have a curfew or don't have a curfew, and honor roll or not honor roll. I think that's just like they do really well at school, essentially. And you can see that this two-way table's been partially filled out and we need to fill the gaps. So we can use those addition things that we were talking about earlier to figure out what the gaps are. And I'm going to start with these 2 numbers because I know that they should add up to equal whatever the total is, right? We know what all of the honor roll students are. So we add up 51 plus 17. So we get 68 students who are on the honor roll. And we can also add up these 2 to work out how many students don't have a curfew. So we add 17 and 21, so we get 38. Okay, and you might get to this point and get a bit stuck. You're like, oh, there's no more 2 numbers I can add up. What we can do now is add these 2, kind of like a puzzle, to work out the overall total, and then we can work backwards to get these 2. I kind of like these because they are a bit of problem solving. So we can add the 93 students who have a curfew with the 38 who don't have a curfew. And what have we got? 101, 130, 131. I hope I did that right. It'd be very embarrassing if I didn't. So we know that there's 131 students total. And now I can work backwards to get this number. But I'm not going to be adding this time, right? Because I'm working backwards. So instead, I'm going to subtract this 68. Okay, so let's quickly do that. So 131, take away 8. So we're going to get down to 123. And then we're going to take 60 away from that. So 163. No, 63. Whoa. Miss Beaching on the weekend is not good at mental arithmetic. Let's check we've added that up right. Yep, we're good. All right. Now we can again use this number to work backwards to find out this missing one. We're going to take 21 away from this 63. So we're going to go 63 take 21, so we get 42. And hooray, we've filled out our two-way table. It's just a bit of problem solving. Usually you're going to be subtracting or adding to find those missing parts. That's it from me. Good luck with this skill, and if you get stuck, let your teacher know. Bye!